now in the third step we have to show that g1 of x, it is lesser than or equals to p of x for all x belongs to the domain of g1. That is we have to show. So for this we consider y comma z be any two elements of script d of f tilde. Then f tilde of y minus f tilde of z, it is equals to, as f tilde is a linear, therefore it is equals to f tilde of y minus z. Also, as y and z, as y comma z, they are the element of domain of f tilde, and domain of f tilde is a vector space. It is a vector space, therefore it is closed with respect to addition and scalar multiplication, and therefore y minus z, that is also the element of domain of f tilde. Also, we know that for all x belongs to the domain of f tilde, we know that f tilde of x, it is always lesser than or equals to p of x. Therefore, using these two conditions, we get f tilde of y minus f tilde of z, that is equals to f tilde of y minus z, and now y minus z, it is the element of domain of f tilde, and for each element of domain of f tilde satisfy this inequality, and therefore f tilde of y minus z, now it is lesser than or equals to p of y minus z. Now this p of y minus z, it is equals to p of y plus y1 minus z. Just by adding and subtracting y1, it is equals to p of y plus y1 minus z. Now it is lesser than or equals to p of y plus y1 plus p of minus y1 minus z, because here we know since p is a sublinear functional, and as it is a sublinear functional, therefore it is subadditive, and therefore applying the property of the subadditive, here we are getting that it is lesser than or equals to p of y plus y1 minus plus p of minus y1 minus z, and therefore here, that means here we are getting that is f tilde of y minus f tilde of z, it is lesser than or equals to p of y plus y1 plus p of minus y1 minus z. Now taking the last term to the left and the term f tilde to the right, we get minus of p of minus y1 minus z, this last term to the left, we are getting minus p of minus y1 minus z minus f tilde of z. Now it is lesser than or equals to, and now we are taking f tilde of y to the right, we are getting that p of y plus y1 minus f tilde of y. Now we are getting this inequality where we know that y1 is the fixed element of capital X, y1 is fixed element of capital X. Now in this inequality, we observe that this term, it is independent of y, and this term, it is independent of z, and therefore here we are taking the supremum over all z, and here we are taking the infimum over all y. Therefore we write down here, since I am giving it the equation number 3, since equation 3, in equation 3 y does not appear on the left side and z does not appear on the right side. So, the inequalities continue. To hold if we take the supremum over z belongs to script d of f tilde on the left and the infimum over y belongs to script d of f tilde on the right. On the right and call it m0 and m1 respectively. That means here in this inequality 3, here we observe that this term it is independent of y and this term it is independent of z. Here y and z be any two arbitrary element of domain of f tilde, and it is true for any two arbitrary element of domain of f tilde. And therefore here as it is independent of y, therefore here we are taking the supremum over z belongs to script d of f tilde, because it is true for any z belongs to domain of f tilde. Therefore this inequality is true for the supremum of also, as well as this inequality is true for infimum of y belongs to domain of f tilde. And therefore this inequality continues to hold for the supremum of this and for the infimum of this, and therefore we are taking the supremum over z belongs to script d of f tilde on this side and taking the infimum over y belongs to domain of f tilde on this right, and we are giving it the supremum equals to m0 and giving it the name m1, that is for the infimum. That means here we are getting that m0 it is lesser than or equals to m. And for a c with m0 lesser than or equals to c lesser than or equals to m1, we have m0 it is lesser than or equals to c, and also we have c that is lesser than or equals to m1. But m0 it is nothing but the supremum over z belongs to script d of f tilde of this inequality, and that means therefore minus of p of minus y1 minus z minus f tilde of z, it is always lesser than the supremum, and that supremum is m0, and m0 it is lesser than or equals to c. Therefore we are getting that minus of p of minus y1 minus z minus f tilde of z, it is also lesser than, which is lesser than or equals to m0, and that is lesser than or equals to c. This implies that minus p of minus y1 minus z minus f tilde of z, it is lesser than or equals to c. Now we give it the equation number 4. In the same way here we have c which is lesser than or equals to m1, but m1 it is nothing but the infimum of all y belongs to script d of f tilde of this, and therefore here we are getting that m1 it as it is the infimum, and therefore it is lesser than or equals to p of y plus y1 minus f tilde of y for all y belongs to the domain of f tilde, because it is the infimum and therefore it is lesser than or equals to of all these. That means we are getting that is C. It is a lesser than or equals to p of y plus y1 minus f tilde of y, and this is true for all y belongs to the domain of f tilde. When we give it the equation number 5, in this way we are getting the equation 4 and 5 that are the inequality. Now we use this inequality to show that g1 of x, it is less than or equals to p of x. So to prove g1 of x, it is lesser than or equals to p of x for all x belongs to for all x, sorry, not y1, for all x belongs to the domain of g1, we prove this inequality for alpha greater than 0, alpha equals to 0, as well as alpha lesser than 0. That means this inequality, we prove this inequality for alpha greater than 0, alpha equals to 0, as well as we prove it for alpha lesser than 0. So first of all, for alpha lesser than 0, that means alpha is negative, then we use equation 4 with z replaced by, because that equation is true for all z belongs to domain of f tilde, and therefore we replace, in that case we are taking the value of z by alpha inverse y, because y it is the element of domain of f tilde and alpha inverse it is the scalar, therefore alpha inverse y, that is also the element of domain of f tilde, and therefore we replace z by alpha inverse y. That is in equation 4 we have minus p of minus y1 minus z. Now z is replaced by alpha inverse y, therefore we are writing here minus y by alpha. Now minus f tilde of, instead of z we are writing y by alpha, and now it is lesser than or equals to c. Multiply both sides by minus alpha, which is strictly greater than 0, because alpha it is here, alpha it is lesser than 0, therefore minus alpha it is positive, and on both sides we multiply by minus alpha, we get here we are getting alpha p minus getting plus alpha p of minus y1 minus y by alpha. Now here minus alpha, it is multiplied with this, here we are getting plus alpha f tilde of y by alpha, it is lesser than or equals to minus alpha c. Now here f tilde is linear and therefore it is written as alpha p of minus y1 minus y by alpha plus f tilde of y. This alpha and this alpha get cancelled, and that is lesser than or equals to minus alpha c. Now therefore now we take this minus alpha c on this side, and therefore we are getting that is alpha c plus f tilde y. Now it is lesser than or equals to, now this term, we take this term on this side, therefore it is lesser than or equals to minus alpha p minus y1 minus y by alpha. Now it is equals to, that is f tilde y plus alpha c, it is lesser than or equals to, now it is equals to, as we know that p is a subadditive, and therefore here as p is a subadditive function, therefore we know that alpha p of x, it is always equals to p of alpha x, and using this equality we are taking here, it is equals to p of minus alpha 1 alpha y1, that becomes alpha y1, that is equals to p of alpha y1 plus y, just by taking minus alpha inside this, because here we know that p of alpha x, that is always equals to alpha px, and therefore here we are getting that when minus alpha, when we can take it inside, we are getting that p of alpha y1 plus y, and it is nothing but g1 of x, and it is nothing but p of x, because here where x equals to y plus alpha y1, and in this way we are getting that is for alpha lesser than 0 we get g1 of x, it is lesser than or equals to p of x. In this way we prove the inequality for alpha lesser than 0. Now we consider alpha equals to 0. Now for alpha equals to 0, when alpha equals to 0, x, that is equals to y plus alpha y1, it is equals to y. Then in this case, then g1 of x, that is equals to f tilde of y. That means here, that is g1 of y, because here x equals to y, and therefore we are getting g1 of y equals to f tilde of y for all y belongs to domain of f tilde. That means g1 equals to f tilde on the domain of f tilde, because it is the extension of f tilde, and therefore and f tilde of y, it is lesser than or equals to p of y for all y belongs to the domain of f tilde. This implies that, but f tilde, it is nothing but g1 of y. This implies that g1 of y, it is lesser than or equals to p of y for all y belongs to domain of f tilde. Now I just write down x instead of y. That is g1 of x, it is lesser than or equals to p of x. This x is the element of domain of f tilde. In this way we show that this inequality is also satisfied for alpha equals to 0. Now we have to prove this inequality for alpha greater than 0. Now here we are taking from equation 5, we have c, it is lesser than or equals to p of y plus y1 minus f tilde of y for all y belongs to the domain of f tilde. That is the equation 5. For alpha greater than 0, we use equation 5. That means this equation. We use equation 5 with y replaced by alpha inverse y, because here this inequality is true for all y belongs to the domain of f tilde, and here as domain of f tilde is a vector space, therefore alpha inverse y, that is also the element of domain of f tilde, and this inequality is true for all element of domain of f tilde, therefore it is true for alpha inverse y also, and therefore we get c, it is lesser than or equals to p of, now y is replaced by alpha inverse y, so we write down p of y by alpha plus y1 minus f tilde of, now y is replaced by y by alpha, and now here we multiply the 6, equation 6 multiply by alpha, which is positive, to equation 6 gives alpha c, it is lesser than or equals to alpha p of y by alpha plus y1 minus alpha f tilde of y by alpha. Now it is equals to, this implies that alpha c, that is lesser than or equals to Now again here we can take inside alpha because p is subadditive, and therefore it is p of. Now when we can take inside this, then we are getting that alpha into y by alpha. This alpha get cancelled, and here we are getting only y and plus alpha y1 minus again f tilde is linear, and therefore alpha into f tilde of y by alpha, that is equals to f tilde of alpha into y by alpha, and that is equals to y, and therefore we write down here minus f tilde of y. Now this imply we take this term f tilde of y this side, we are getting f tilde of y plus alpha c, it is now lesser than or equals to p of y plus alpha y1. Now f tilde of y plus alpha c, that is nothing but g1 of x, and it which is lesser than or equals to p of, now y plus alpha y1, it is nothing but x. That means here we are getting that g1 of x, it is lesser than or equals to p of x. That is for alpha greater than 0, we get g1 of x, it is lesser than or equals to p of x. And it is true for all x belongs to the domain of g1. That means we get that is g1 is a linear extension. It is a linear extension of f satisfying g1 of x lesser than or equals to p of x for all x belongs to the domain of g1. And as it is a linear extension of f satisfying this condition, this implies that g1 belongs to E. E is nothing but the set of all g such that g is a linear extension of f, satisfying g of x, it is lesser than or equals to p of x. And capital E has a maximal element, f tilde. Therefore g1 must be lesser than or equals to f tilde. But in second step we show that g1 is a proper extension of f tilde. And as it is a proper extension of f tilde, therefore g1 lesser than or equals to f tilde is not possible. Thus g1 lesser than or equals to f tilde is not possible. Therefore this gives contradiction. And therefore our assumption that domain of f tilde, it is not equals to capital X is wrong, and hence domain of f tilde, it is equals to x. In this way we are showing that domain of f tilde equals to x. In this way we are find out the extension of f satisfying the property that f tilde of x, it is lesser than or equals to p of x. In this way we prove the Hahn-Banach theorem for extension of linear functionals.